We will learn the first chapter in science, laws of motion. In this, we will study what is motion, what is acceleration, distance and displacement, and also Newton's laws of motion and other related equations. So let's begin. Motion of an object. So what is motion? Motion is nothing but the movement of an object. Can you tell in which of the following examples can you sense motion, that is movement, and how will you explain presence and absence of motion? So let's see the examples. The flight of a bird, a stationary train, leaves flying through air, a stone lying on a hill. So we have to tell from these examples which one has motion and which one does not. The flight of a bird, that is a bird which is flying. So in this, the wings of the bird are in motion. Therefore, this example has motion. A stationary train, which is a train which is at rest. So because it is at rest, it is not moving and therefore it does not have motion. Leaves flying through air. So in this, it is saying that the leaves are flying through the air. That is, they have motion. A stone lying on a hill. So in this, the stone is just lying on the hill and not moving. So this one does not have motion. We see the motion of several objects every day. Sometimes we cannot see the motion of an object directly, as in the case of a breeze. Can you list other examples of motion besides those given here? So they are saying that every day we can see something or the other in motion or which is moving. But sometimes even though something is moving, we cannot see them. Like breeze. So in breeze, the air is moving, but we cannot see air. That's why we cannot see when the air is moving. Think about it. You are traveling in a bus. Is the person sitting next to you in motion? What do you take into consideration to decide if an object is moving or not? You have learned that motion is a relative concept. Means it is always considered in respect to other things around it. If the position of an object is changing with respect to its surroundings, then it is said to be in motion. Otherwise, it is said to be at rest. So, when you are sitting in a bus and when you see the surroundings outside, then you can say that you are in motion relative to the outside surroundings. But when you see the person sitting next to you, that person is not in motion with respect to you. Now we will study about displacement and distance. Let's try this. Measure the distance between points A and B in different ways as shown in figure 1.1. So this point A and this point B, we have to measure in different ways possible. So we can directly join those points or we can go around those points and we can measure all the distance between A and B. Now measure the distance along the dotted line, that is the direct line that we drew from A and B. Which distance is correct according to you and why? So which distance do you feel would be correct in order to measure them? It would obviously be the point from A to B. Think about it. Sheetal first went to her friend Sangeeta's house on her way to school. Prashant went straight from home to school. Both are walking with the same speed. Who will take less time to reach the school and why? So in this image we can see that Sheetal and Prashant, they stay in the same house and Prashant directly went from his house to school. And the distance between Sheetal and Prashant's house and the school is 1300 meters. Whereas Sheetal first went to Sangeeta's house, so she travelled 500 meters this way, and then from Sangeeta's house she went to school, so she travelled another 1200 meters. So Prashant total he walked around 1300 meters, but Sheetal walked 500 plus 1200 meters, that is 1700 meters. So as you can see here, Sheetal travelled 1700 meters, that is more than 1300. So since Prashant's house and the school is 1300 and he went directly, he travelled lesser than Sheetal. Distance is the length of the actual path traveled by an object in motion while going from one point to another, whereas displacement is the minimum distance between the starting and finishing point. So let's understand what is the difference between distance and displacement in the above example. So here Sheetal went from her house to Sangeeta's house and then from Sangeeta's house to the school. So for Sheetal, the starting point was her house. We'll name it as A, and the finishing point was the school. We'll name it as B. So in order to go from A to B, Sheetal travelled 500 plus 1200 meters, that is 700 meters. But Prashant, he went from A to B directly. So the distance travelled by Sheetal would be 1700, but the displacement would be the direct line joining A and B, that is 1300. So displacement is the minimum distance that you can travel in order to go from the starting point to the ending point, and in this example it is 1300. Use your brain power. Every morning, Swarali walks around the edge of a circular field having a radius of 100 meters. So this is the circular field which has a radius of 100 meters. She starts from point A and takes one round. How much distance has she walked and what is her displacement? So she starts at point A and takes one round of the circle, and they are asking us to find what is the distance and what is her displacement. So how do we calculate the distance that she's traveled? That is, this is the starting point and this is the ending point. So her distance would be calculated by taking the circumference of the circle, which is 2 pi r, and in this case r is equal to 100. But her displacement would be 0. Why is that? Because the starting point and ending point are 1. So because the starting and ending point are a single point, the displacement will be 0. Let's see the second example. If a car starting from point P goes to point Q and then returns to point P, how much distance has it travelled and what is its displacement? So the car is starting from point P, going to point Q and then coming back to point P. So the distance travelled would be 360 plus 360 or 360 into 2, because this point P to point Q is 360. Whereas the displacement again would be 0, because here also the starting point and ending point is point P. So as we seen here, even if the displacement of an object is 0, the actual distance traversed by it may not be 0. So now we will study about speed and velocity. Can you recall what are vectors and scalars? Which of the quantities distance, speed, velocity, time and displacement are scalars and which are vectors? If you want the answers to these questions, go to www.jkacademypro.com. So as we had seen earlier, speed is equal to total distance travelled upon the time required by the object to travel that distance. So this is a very important formula. The distance travelled in a particular direction by an object in unit time is called its velocity. So what is exactly the difference between velocity and speed is that velocity of an object changes based on the direction that the object is in and the direction in which the object is travelling. Here, unit time can be 1 second, 1 minute, 1 hour, etc. So the unit time, it can be anything. If large units are used, 1 year can also be used as a unit of time. The displacement that occurs in unit time is called velocity. So when we have to calculate velocity, we need to take the displacement occurred by the object. But when calculating speed, we take the distance in the formula. Always remember, the units of speed and velocity are the same. In the SI system, the unit is meter per second, while in the CGS system, it is centimeter per second. So since the formula for speed and velocity is the same, therefore the units are also the same. And this is a standard system that uses units. So if we solve a problem in the SI system, we have to take meter per second. But if we use CGS system, it will be centimeter per second. Speed is related to distance while velocity is related to displacement. So in the formula, when we have to calculate speed, we need to take distance, and when we have to calculate velocity, we have to take displacement upon time. If the motion is along a straight line, the values of speed and velocity are the same. Otherwise, they can be different. So, as we seen earlier, velocity changes based on the direction of the object. So, if it is a straight line and the object is traveling in a straight manner, then velocity and speed of that object will be the same. Velocity is the displacement that occurs in unit time. So, this is just the written way of the formula. Velocity is equal to displacement upon time. Effect of speed and direction on velocity. So now we will see how changes in speed and direction affect velocity. Sachin is traveling on a motorbike. Explain what will happen in the following events during Sachin's ride. So, what will be the effect on the velocity of the motorcycle if its speed increases or decreases but its direction remains unchanged? So, we had seen earlier that velocity changes with respect to speed and direction. But here the direction is unchanged. So, if the speed increases, velocity will increase, and if the speed decreases, velocity will decrease. In case of a turning on the road, will the velocity and speed be the same? If Sachin changes the direction of the motorcycle keeping its speed constant, what will be the effect on the velocity? So now, when changing the direction, we've seen that velocity changes even if the speed is the same. So, even though the speed is constant, as Sachin changes direction, velocity will also change. If on a turning Sachin changes the direction as well as the speed of the motorcycle, what will be the effect on its velocity? So this is what we see in normal life also. When you change a direction on the motorcycle when taking a turn, you have to decrease the speed. So here the speed and direction both are changing, and therefore the velocity will also change. It is clear from the above examples that velocity depends on the speed as well as direction, and that velocity changes by three things: changing the speed while keeping the direction same, changing the direction while keeping the speed same, and changing the speed as well as the direction. So velocity will change if either the speed changes, if either direction changes, or if both speed and direction both change. Always remember, the first scientist to measure speed as the distance upon time was Galileo. So Galileo was the first person who made this formula and used it to measure speed of different things. The speed of sound in dry air is 343.2 meter per second. So this is the speed of sound, while speed of light is about 3 into 10 raised to 8 meter per second. So when you write 10 raised to 8, it is actually 1 followed by 8 zeros. So the speed of light is much faster than the speed of sound. The speed of revolution of Earth around the Sun is about 29,770. What is uniform and non-uniform linear motions? Amar, Akbar and Anthony are traveling in different cars with different velocities. The distances covered by them during different time intervals are given in the following table. So, in this table, we have been given the time as well as the distances covered by Amar, Akbar and Anthony respectively. Use your brain power. What is the time interval between the notings of distances made by Amar, Akbar and Anthony? Who has covered equal distances in equal time intervals? Are all the distances covered by Akbar in the fixed time intervals the same? Considering the distances covered by Amar, Akbar and Anthony in the fixed time intervals, what can you say about their speeds? If an object covers equal distances in equal time intervals, it is said to be moving with uniform speed. So what is uniform speed? Take an example of this line from point A to point B. If we divide this line into equal segments, suppose each of the segment is 1 meter and an object is traveling from A to B and crossing each of these segments in equal time intervals, then it is said that this object is moving with uniform speed. If an object covers unequal distances in equal time intervals, it is said to be moving with non-uniform speed. For example, the motion of a vehicle being driven through heavy traffic. So, when you're driving in traffic, you have to cover unequal distances in equal time intervals. So, what does this mean? When we are traveling in traffic, we have to stop our car again and again. So, because of this, unequal distances are traveled in equal time intervals. So, when we are driving in traffic, we are said to be in non-uniform speed. So now we will study about acceleration. Take a 1 meter long plastic tube and cut it lengthwise into 2 halves. So when you take this tube and cut it lengthwise, it will no longer be a tube like this. Take one of the channel shaped pieces. Place one of its ends on the ground and hold the other at some point from the ground. So as you can see here, this channel, one end is placed on the ground here and the other side is held on top at some height. Take a small ball and release it from the upper end. So you have to take the ball over here and release it down. Observe the velocity of the ball as it rolls down along the channel. Is the velocity the same at all points? So when the ball is rolling down, you have to observe very carefully the speed and velocity of the ball. Observe how the velocity changes as it moves from the top through the middle and to the bottom. So in the top part of the channel, see how fast the ball is, and as it goes lower, see if the velocity of the ball is changing. You must have all played on a slide in a park. You know that while sliding down, the velocity is less at the top, it increases in the middle and becomes 0 towards the end. So when you slide on a slide in a park, you will observe that when you just start on the slide, you are very slow. But as you go down and down, your velocity increases, that your speed keeps on increasing. The rate of change of velocity is called acceleration. So, the rate, that is how fast the velocity is changing, that is called acceleration. And acceleration is calculated by change in velocity upon time. If the initial velocity is u, and in time t, it changes to the final velocity v, then what will be the acceleration? So we have to just substitute the formula with these initials. Acceleration a would be equal to final velocity minus initial velocity upon time. So change in velocity is equal to final velocity minus initial velocity. So we put this in the formula and we get a is equal to v minus u upon t. Use your brain power. When an object is at rest in the beginning of its motion, what is its initial velocity? So they are telling us that before it starts its motion, the object is at rest. That is, it is not moving. Therefore, the initial velocity would be 0. And initial velocity is usually taken as u. So, in this case, the initial velocity, that is u, would be 0. When an object comes to rest at the end of its motion, what is its final velocity? So, at the end of the motion, it is at rest now. So, because it is at rest, the final velocity would be 0. And final velocity is usually taken as v. So, in this case, the final velocity, that is v, would be 0. If the velocity of an object changes during a certain time period, then it is said to have an accelerated motion. So, as we saw earlier, as you were sliding down the slide, your velocity kept changing. So, when the velocity changes, it is called an accelerated motion. An object in motion can have two types of acceleration. The first type, if the velocity changes by equal amounts in equal time intervals, the object is said to be in uniform acceleration. If the velocity changes by unequal amounts in equal time intervals, the object is said to be non-uniform acceleration. So, as we saw before with uniform velocity and non-uniform velocity, similarly with acceleration there is uniform and non-uniform acceleration. So, if the velocity was changing equal amounts in equal time intervals, then it was uniform. But if it was unequal amounts in equal time intervals, then it would be non-uniform acceleration. Now we will see what is positive, negative and zero acceleration. An object can have positive or negative acceleration. When the velocity of an object increases, the acceleration is positive. In this case, the acceleration is in the direction of velocity. So when the velocity and acceleration are in the same direction and velocity is increasing, then acceleration is said to be positive. When the velocity of an object decreases with time, it has negative acceleration. Negative acceleration is also called deceleration. Its direction is opposite to the direction of velocity. So, when you want to understand what is negative acceleration, imagine that you have thrown a ball on the ground and after some time it comes to a rest. So, during the ending period, the velocity of the ball goes on decreasing. So, during this time, the acceleration acts on the ball in the opposite direction, whereas the velocity is in the forward direction. So, since the velocity is decreasing with time, it is said to be negative acceleration. If the velocity of the object does not change with time, it has zero acceleration. So now we will learn how to plot a distance time graph for uniform motion. The following table shows the distances covered by a car in fixed time intervals. Draw a graph of distance against time, taking time as the x-axis and distance along the y-axis. So here this is the x-axis and we take time on it, and on the y-axis we will take distance, and we have to use the values given in this table to plot the graph. So as you can see here, the first one, when time is 0, the distance traveled is 0. So that will be this point over here, when both the y-axis and the x-axis are intersecting at 0. Then when time is 10 seconds, so on this x-axis the time 10 seconds is there and distance is 15. So we have to join the lines between 10 and 15 on the x and y axis and make a dot. Similarly, we do it for all the values and you will get dots like this shown over here. When you join the dots, you will get a straight line. Therefore, it tells you that this is uniform motion. An object in uniform motion covers equal distances in equal time intervals. Thus, the graph between distance and time is a straight line. So, because the object was in uniform motion, the graph would be a straight line. Now we will study about distance time graph for non-uniform motion. The following table shows distances covered by a bus in equal time intervals. Okay, so now the time intervals are equal, but the distance traveled is not equal. So this is just a representative graph in which the A curve what we see is what we would get when the object travels in non-linear motion. And the B graph was what we saw earlier, and this was when the object travels in uniform motion. Use your brain power. What differences do you see in the distance time graphs for uniform and non-uniform motion? So this is the same thing that we seen earlier in this graph. In uniform motion, the graph would be a straight line, whereas in non-uniform motion, the graph would be a curve. The next topic we will learn is velocity time graph for uniform velocity. A train is moving with a uniform velocity of 60 km per hour for 5 hours. The velocity time graph for this uniform motion is shown in the figure. So here on the y-axis we have been given velocity in kilometer per hour, and we know that the train is traveling with uniform velocity of 60 km per hour. So because it is uniform, it will be a straight line parallel to the x-axis at 60 km per hour. With the help of the graph, how will you determine the distance covered by the train between 2 and 4 hours? So on the x-axis we have the time in hours, and we need to find the distance covered by the train in 2 and 4 hours. So how would you do this? As we learned earlier, the velocity is calculated by velocity is equal to displacement upon time. So we just have to substitute in the formula. Velocity we know is 60 km per hour, and the time would be 2 hours because we need to find between the second and the fourth hour. Is there a relation between the distance covered by the train between 2 and 4 hours and the area of a particular quadrangle in the graph? So if you calculate the distance, it would be equal to this quadrangle in the middle, that is quadrangle ABDC. So once you calculate the distance, it will be equal to the area of this quadrangle. What is the acceleration of the train? As we had learned earlier, acceleration is the rate of change of velocity per unit time. But here, the train is traveling with uniform velocity. That is, it is not changing with respect to time. So, the acceleration for uniform velocity would be 0. See the velocity time graph for uniform acceleration. The changes in the velocity of a car in specific time intervals are given in the following table. So once you plot this table, you will get a graph like this. And this graph is little different than the previous graph, because in the previous graph the line was parallel to the x-axis, but here it is not. So if we have to find the distance traveled by the car in between the 10th and the 20th second, then we can calculate it similarly. The only difference is that when we have to take the velocity, we'll have to take the average of the 2 points. So now because we have to find the velocity between 10th and 20th second, and they are not the same. At the 10th second the velocity is 16 meter per second, and at the 20th second the velocity is 32 meter per second. So we have to take an average of the two. And how do you do that? Is you take 16 plus 32 divided by 2. And whatever you get, the answer would be the velocity. So you take that velocity and time would be 10 seconds because 20 minus 10 is 10 seconds. And you will get the distance. This distance will be equal to the area of this quadrangle, that is quadrangle ABCD. And since this quadrangle is not a proper rectangle or square, we'll have to calculate it by first taking area of this square, that is quadrangle AECD, and adding it to the area of this triangle, that is triangle ABE.